we're supposed to solve this as a pair of simultaneous equations. So I'm going to let this be equation 1, and I'm going to let this be equation 2. So if I were to let equation number 1 be equal to equation number 2, the y will be happening simultaneously, which means that 2x squared minus 7 will be equal to 3x plus 20. Shifting everything over to the left-hand side, 2x squared minus 3x minus 27. This is equal to 0. And factorizing this, we have x plus 3 and 2x minus 9. This is equal to 0. So x is going to be equal to minus 3, or x is equal to 9 over 2. And when x is equal to minus 3, we will be able to solve for the corresponding value for y. I can either use equation number 1 or 2. I think I'm going to use equation number 2. So this is 3 multiplied by minus 3 plus 20. So y is equal to 11. And when x is equal to 9 over 2, y will be equal to 3 times of 9 over 2 plus 20. And this is equal to 67 over 2. If we were to sketch the graph of y is equal to ax squared plus 5x minus 2, for this graph to be such that it is negative for all values of x, this graph must be a set phase that is going to be below the x-axis, so that all the possible values of x will give me y coordinates that are negative. And in order for this to happen, we will need two conditions. Number one, we will look at the coefficient of x squared, since we are looking at a set phase, so the coefficient of x squared must be less than 0. Then we are going to look at the discriminant, because the discriminant tells us when this is equated to 0. That means when I'm trying to compare this graph against the line y is equal to 0, they are not going to be intersecting. So when I equate this to be equal to 0, the discriminant must be less than 0, such that there's no solution to this. So there's no solution to this line and this graph. So using these two conditions, I'm going to try to find the greatest possible value for a. So first, I'm going to be letting a to be less than 0. Then we're going to be looking out for the values of a such that the discriminants are less than 0. Discriminant. The discriminant must be less than 0. So for the discriminant to be less than 0, it's going to be b squared minus 4ac. It must be less than 0. So 25 plus 8a, this must be less than 0. So a must be less than minus 25 over 8. And minus 25 over 8 is minus 3 and 1 over 8. So what is the greatest possible integer value of a? The greatest possible integer value of a is going to be equal to minus 4. We're given that this line and this curve, they are tangent to each other. So what I'm going to do is I'm going to solve this as a pair of simultaneous equations. So I'm going to let equation number 1 be equal to equation number 2. So 4x plus c is equal to x squared plus cx plus 21 over 4. Then shifting everything over to the right hand side, we have x squared plus cx minus 4x plus 21 over 4 minus c. This is equal to 0. So combining all the coefficients together for the same powers of x, we have this as c minus 4x, then plus 21 over 4 minus c. This is the term that is independent of x. And since the question says that this line and this curve, they are tangent to each other, which means that they're going to be touching at just one point. So for this quadratic equation that we have derived at, it should have only one solution. So since it has only one solution, we are going to let the discriminant be equal to 0. So by letting the discriminant be equal to 0, we will get an equation that is c minus 4 squared minus 4 times 1 times 21 over 4 minus c is equal to 0. We get an equation in terms of just c. We're going to solve this equation and we will be able to get the values of c. So expanding this, it is c squared minus 8c plus 16. Then minus away this is going to be equal to 21 plus 4c. This is equal to 0. So we'll get a c squared minus 4c minus 5. this is equal to 0. Factorizing this, it is going to be c plus 1 and c minus 5. This is equal to 0. So c is going to be equal to minus 1 or c is equal to 5.